Kick ass in chemistry with the factor label method.
I can tell right away whether a college student will be successful in college chemistry by watching the student solve a very simple elementary school type of a question. Today, I'm going to show you how to use the factor label method utilizing conversion factors in the easiest way to solve this kind of a question. So we want to know how many millimeters are in 65 centimeters. So what we do is we start off with the 65 centimeters that we want to convert. And the next thing we are going to do is we are going to try to find a conversion factor that will convert centimeters. Now, we won't get our millimeters right away because I don't know how many millimeters are in a centimeter, but I do know that there are 100 centimeters in 1 meter. Now, this thing over here is called a conversion factor. And this little zero didn't fully manifest. Okay, so this is called a conversion factor. Now, first of all, why is it called a factor? The reason why a conversion factor uses the term factor is because we use it in multiplication. And remember, factor times factor equals product. But I want you to also see something that's really, really important in this idea. There are 100 centimeters in 1 meter. That makes this fraction a disguised form of the number 1. It doesn't look like a 1. It looks like 1 over 100. But it's not 1 over 100, really. This is the number 1. But the units are absolutely necessary in understanding that this is a disguised form of 1. But this is exactly what's necessary in a conversion factor. But look what happens. See, the centimeters cancel. They cancel like they are numbers. Units will actually behave like they are numbers if used properly. So now we've converted the 65 centimeters into meters. But we don't want our answer in meters. We want our answers in millimeters. And I know that there are 1,000 millimeters in 1 meter. So we're going to need another conversion factor. The student always asks me when they're first learning this problem, they say, well, what do I put in the numerator? What do I put in the denominator? And I say, well, it depends what you want to cancel. See, we want to cancel out meters. So we put the meters in the denominator. They will cancel. And we want to be left with millimeters. That's what we want. So we're going to put the millimeters in the numerator. And we know that there are 1,000 millimeters in 1 meter. Now look what happens here. This is great. The meters cancel. And the only unit that is left is millimeters. Now something else really nice happens. This 0 cancels with this 0. This 0 cancels with this 0. And we're left with 65 times 10 millimeters. Now I know 65 times 10 is 650. And that is our final answer. So to review, what did we do? We started off with our 65 centimeters. We used a disguised form of 1, also known as a conversion factor. We made sure we had centimeters in the numerator to cancel this out. And I knew that there are 100 centimeters in every meter, which makes this a disguised form of 1. So multiplying this by this changes nothing other than the units. Then we had to do the similar process knowing that this is a disguised form of 1 because there are 1,000 millimeters in 1 meter. So essentially, to get this problem, what we did was we took the 65 centimeters and we multiplied this by two disguised forms of 1, which were each conversion factors. Now, this is a pretty simple elementary school level problem that could be done without using the factor label method. But the factor label method is necessary in college chemistry because you will have a string of these conversion factors in a typical college chemistry problem, and you will have more than just 2 steps. But if you can introduce the student to this idea early when they hit college chemistry, they will hit the ground running.